Hey everybody, Laser Wizard here. I finally got a chance to put my Vasto through the works, machining some aluminum plates. I've already finished them and sent them off to the customer, but I've recorded the whole process and I would love to show you how it all went. I start off by gluing down an additional wasteboard, surfacing it, and then doing the painter's tape and CA glue method to hold down the plates. And I've got a very special offer for you guys. If you decide you want to get yourself one of these beasts of a machine for yourself, and if you buy it with my affiliate link, I'll send the first 5 people a free pallet holder and tool holder. This thing I just made to help organize all my bits. I've got a 2.2 kilowatt spindle that I installed. I had to make a custom adapter plate to mount it, but it uses ER20 collets, and I can go up to 1/2 inch. So yeah, let me know if you decide to get it. Just reach out to me, contact me, and we'll work it out. So I'm going to show you guys the process of how I glued it down and machined it all. And honestly, it did a phenomenal job. So hopefully you can bear through it all. Alright, I've super glued this piece of plywood to the bed in hopes of stiffening it up a little bit and giving me a better work surface area here. And I'm about to surface it with my carbide insert. Well, I guess they're brazed on carbide surfacing bit. 1/4 inch shank, I think 1 inch diameter. Alright. Alright, just freshly vacuumed, and it did pretty good. Should I say it did okay? Definitely 10 out of 10 don't like this type of surfacing bit. For one, there's no rake angle, it's all neutral. It's not sloped in any way. The very bottom is angled very slightly, as you can see that. But not this edge here, nor this front face. So that just kind of makes it smack. And I wanted to turn the RPM down so that it wasn't burning it like it did a little bit here. But then it would start making a lot of noise. And I believe it's the bit's fault. No biggies. And despite being able to see this pattern, I can just almost barely feel it. So I'll just hit it very lightly with some sandpaper just to take some of these hairs off. And then we'll get on to the main event. Okay, here it is just right after sanding. I just wanted to show you guys how lucky I got on my measurements here. On this left side, you can see a little lip there. And in the midsection, this plywood was much thicker all the way up to the back. So along the back, when I was doing the full millimeter depth of cut, I had it set to take 1 millimeter off. And I zeroed it off in the middle, knowing that this front was thinner. But look at that. Like, I almost thought it didn't machine it here, but it just did. So the whole entire area's been leveled. And unfortunately, that's the entire depth of my y-axis for now, because I have a little issue where Something's colliding back here. I need to take a close look, but I'm not hitting the limit switch, and it's keeping me from going all the way to the back. That's fine. Plenty of room for now. Next, I'm going to lay down some tape and put down the stock. It's going to be tape upon tape upon tape. So this is the stock we're starting off with. It started off as a extruded half-inch sheet of aluminum, which I learned the extruded aluminum not good to machine. It came very warped, and it was just very hard to machine it flat. I tried to get it down to 10 millimeters, and it's about 10 right in the middle. A little bit thinner on the ends, but that's fine. So I'm going to fixture it by doing the painter's tape and super glue method. And after the surfacing, I specifically left a ridge here, which I know is parallel with my y-axis, no matter what. And that's what's going to be my reference. So since I'm going to be doing machining all the way and cutting it out, I don't want to machine outside of my bounds. So I'm using a little spacer here to offset my stock. And we're going to put some super glue, spray some activator, and drop it down. And hopefully it sits nice and flat. The glue I'm going to be using is this 2P10, the thick stuff. Although I kind of recommend maybe the medium stuff. And I'm going to use some spray activator. Maybe. I'm still kind of on the rocks. The thing is, once you drop the plate down on this, it's instant. Like it's stuck. And that doesn't quite give you time to align everything perfectly and maybe smush it down all the way flat. It might cure on you before it all levels out. So actually, I think I'm not going to use the activator. I'm just going to do the super glue, and I'm going to put a weight on it, and I'm going to give it a good few minutes to cure before I start doing anything. That way I can make sure I can lay it as flat as possible. Now, there's going to be a couple pockets I'm going to be cutting out, and I want to make sure they don't come loose. So I'm going to try and get this pretty well covered in the super glue. It's really hard to know what is enough glue and what isn't, but it's usually better to be on the safe side. Okay, so that's pretty square. This thing slips with a little bit of resistance. We'll let it cure, and then we'll put in our bit and zero it and get to cutting. While I give that as much time as I can to cure, I'll go over the 3 bits I plan to use on this job. And these are it here. First one on the left is a 1/8 inch single flute upcut bit, and we've got a 3/16 single flute upcut bit, and then 1/4 inch diameter 4 flute solid carbide 90-degree chamfering bit. And the 1/8 inch bit is a SPE tools. The 3/16 is a LMT Onsrud, and the chamfer bit is a Speed Tiger. And the first one I'm going to use is the 1/8 inch one to bore the tiniest holes, which the 3/16 bit can't fit into, and then almost 99% of the work is going to be done with the 3/16 bit. I've used this bit once before, and I just today resharpened it by hand a little bit. Hopefully it works well. I'm sure it'll take the material out. And then we'll make sure to chamfer all the edges like pros. Alright, and there we have it. There's our little bit. Okay, next thing I'm going to do is probe for the XY0. And I wrote a special macro for this. Although UGS does have a probing module built in, which works very well and I've used before, but I have the macro I wrote it, might as well use it. So I'm gonna, well, first I'm gonna jog my bit over into the general area. I'm gonna lower the step amount to 1 millimeter. Okay, and I think right about there should be a good starting point for my probing. There we go. Okay, maybe right here. Alright. And I like to hold this down to ensure good continuity. And let's probe it. There we go. The last line of code in my probing command is to jog the machine over to the XY0. That way I can visually make sure everything was set properly. Next thing I'm going to set is the 0 point. I'm going to jog the machine over to the middle of the workpiece where I know it's the fattest and likely at the highest. I'm going to 0 it there and then run the first code. Now, I'm a pretty old school type of guy, and I mean, I do usually, well, not usually, but I have probed the surface before, but it's just a little nerve-wracking the thought of plunging my bit down into the material. So I just kind of got used to doing it with a piece of paper. And I just jog it down 0.1 millimeters at a time until it catches the paper, which is I'm going to be on the next click right here. Paper's caught. I'm going to hit Z0. And I'm going to jog it up and out of the way. Alright, now that the X, Y, and Z axes are zeroed, I'm going to pop my boot on. Just like so. I'm going to make sure this is in well. And then the last step is to get my air nozzle where it needs to go. Okay, so one more time, X, Y, and Z are zeroed. My first code is loaded. I've got my feed rate override set to about 80%. And I'm going to run the vacuum, the air assist, so it's going to get noisy. So, much to my surprise, everything actually went pretty smooth, and the surface finish looks great. Let's take a peek. Those holes look very smooth. Alright, now all the rest of the operations are going to be with a 3/16 bit. That's what I'm going to swap to next, zero the Z, and cross my fingers. So I just checked these holes, and I'm surprised they're very close. Got some calipers here. They're not the best for measuring small hole diameters, but better than nothing. And my calipers read about 0.03 of an inch undersize, so keep that in mind. And obviously it takes some wiggling to get a reading. But man, I think that's close enough. I mean, I was going to just drill these through anyway. But I think they're ready for a M6 tap. Here's how this bit looks. If I can get this focused. Let's see here. There we are. Now, as you can see, it's gummed up already. And when you're giving it to aluminum dry, you know, it doesn't like it too much, obviously. But it's good enough for a few operations. But what I do, I soak these in lye, which is actually I got at the dollar store called Mr. Plumber, but any drain cleaner has it. It's just a very basic solution, and it dissolves the aluminum. So I make sure all my bits today, I soaked in my drain cleaner so that there's no buildup on them. That way, from the start, there's minimal friction, and obviously halfway through it's going to build up, and for the second half it's going to be gummed up. But if you start off with a gummed up bit, then that's just a big snowball effect from the beginning. cautious, as always, and as you should be. I've kept the XY zeroing, didn't lose that. As you guys saw, re-zeroed the 3/16 bit. Got the air assist pointed at it. I've got the next code loaded. Feed rate override at 80%, just, you know, be on the safer side. And man, we're gonna send it. Alright, another successful operation, I hope. I'll check the dimensions and I might give it another pass if it needs a little bit more. But I doubt it, I'm sure it's good. What I'm going to do is I'm going to just check the temperature of the plate real quick, and I'm going to inspect the bit to look at the buildup. And if there's enough buildup on it, I might actually dip the tip in my lye solution just to clean it off without actually pulling it off the machine and messing up the zero. So let's take an inspection. So as it turns out, the next operation is the finish boring operation for those holes. So that should bring them back up to spec. Also, that's something that, I mean, you kind of shouldn't do, but it's a way to trick the system. I noticed in those 4 bigger holes, it was supposed to machine it all the way through, but it left very thin skin. So I set my Z 0.2 millimeters lower. Hopefully doesn't collide in any of the other operations. I usually have a 2 millimeter approach distance or clearance height anyway. So now hopefully the finish boring operation will take out that bottom skin and bring those holes up to size. Okay, that went very well. I'm going to turn the vacuum on, load the other code, the next one in line, which is a pretty major operation. It's going to make these 2 big cutouts, and I'm really hoping that they don't bust loose from the heat. We're up to 100% feed rate. I picked that up earlier on. Let's hope for the best. Okay, man, that was intense, but I think it came out beautiful. So I'm looking at this bit as closely as I can, and other than the blue masking tape glue residue, it honestly doesn't look like there's almost any aluminum buildup. So I'm just gonna keep running it. And man, these surface finishes are just incredible. Let's see if I can get in closer before I vacuum it. It's like a mirror finish. And if you notice, while I was machining, it kind of looked like there was a lot of like burrs piling up along some of the edges. But that's actually because when you're doing a slotting operation, you're actually doing conventional milling on one side of the cutter, and you're doing climb cutting on the other side. So the side that gets the climb cutting, you can see the reflection of those chips down there. You see those chips? And this is with a pretty much, unupgraded bed. It's still just the regular bed. I glued a 1/2-inch piece of plywood to it. That definitely stiffens it. And having this aluminum plate glued down also, helps stiffen it. But there is flex in the gantry, a very little bit. But I think having a massive 2.2 kilowatt spindle gives it, not only the rotational inertia because of the heavier armature, but the mass to absorb the vibrations before transmitting them to the rest of the machine. So I'm going to get the vacuum out and vacuum it so that we can get a slightly better look. And I'll probably pry these little squares out so that they're not in the way anymore. We'll see how it looks. And before I vacuum up the chips, I just wanted to show you guys the quality of them. And for the most part, I think they're very nice, consistent, and fairly large chips. There's some blue painter's tape. And then I ran finishing passes and a repeat finishing pass at full depth. That's what explains these little long hairs. I did that at 0.1 millimeter step over. That's why those are very thin. It might have actually been 0.07 millimeters. I don't 100% remember. And I don't actually recall what the chip load is, but I think it's about 1 thou. So these chips should technically be about 1 thou thick, but I'll have to double check in the cam. So there's just some chips kind of clung to the sides here. They'll wipe right off. These bore holes, look, it's reflecting the whole blue. Those are just a couple specks of debris, just like that one. This one's pretty clean. Well, there's some debris there. Man, not bad. Especially for not even gumming this thing up. It's when you have your feeds and speeds just right. I'm feeding at 1,000 millimeters a minute, 1 millimeter depth of cut, and the plates barely got warmer than room temperature. This one I can feel a little bit of warmth on, but no budge. Alright, I pried out those squares. I'm going to load the next code. We're going to continue on with the operations here. Alright, this came out great too. I'm just going to take a glance at the bit, make sure it's not gummed up. So I'm looking at this bit, and you see on this edge there is a little bit built up, and you can see down at the very bottom, the way they grind these, they put these flutes along the back edge, and as you can see on the bottom, you can't really see those flutes there. That's a little bit of tinning with aluminum. And this would probably just brush off, and honestly will probably be still good for cutting, but I'm just gonna freshen it up, and I think I got an idea how to do it very quick and easy. So bear with me here. Okay, I've soaked the bit for a little bit. It cleaned it up. Most of the stuff came off. Got the final code loaded. The 6th step contour cutout. And it's been a long journey so far. And hopefully nothing messes up at the very end. Alright, that concludes the biggest operation, the longest run. And it looks great so far. Absolutely amazing. So I'm going to put in my 90-degree chamfer bit next and finish this thing off, hopefully. Alright, here is the final operation, at least on this machine here, for this plate. And I got my 1/4" 90-degree 4-flute solid carbide chamfering bit installed, zeroed out, and I'm not going to run the vacuum. Nah, you know what, I will run the vacuum. So I realized I did not include this little hole right there in the chamfer. So I'm gonna go make one more tool path. Check this out. This is right after vacuuming. And this is just some, I think of that sticker glue. But it's, man, it's reflecting these frizzles perfectly here. And look at these chamfers. You don't want too much of a chamfer, you want just enough. And I like how it's like a mirror finish on that chamfer. And check out these pockets. And the face finish is great. The side finish is phenomenal. both of them. I mean, it's just a flawless execution. I mean, well, not flawless, but man, for a hobby machine in my basement, this is like production quality work. I was afraid these transitions wouldn't blend well, but they look super smooth, you can't even tell. And notice, here's the surface finish if you do conventional milling on a CNC router. Nasty. Compared to ply milling. And what I did, my trick that I just recently started doing, I do what's called roughing passes. And what that means is I don't just do my counter all in just one spiral. The roughing pass first does one offset a little bit. And I did mine just 2 millimeters. So it first goes around offset by 2 millimeters, and then it steps over 2 millimeters and does the actual contour. And the importance of that, it doesn't really matter here or here or here, because I cut the stock down to size pretty well, but I left this on purpose. So this would have been a deep, full width slotting operation, which is just terrible, terrible if you're doing aluminum. You do not want to do deep slotting. So I did the roughing. So I always had, when I was doing this contour, the actual one, there's a 2 millimeter gap on the other side of the cutter to let the chips come out and fly out. Because if you do full width slotting, then those chips hit the cutter on the back side and they bump the cutter over, and then you'll see those surface defects on the face. Just one little hint and strategy of many that I've picked up that are necessary for, I mean, decent outcomes here, especially with aluminum. Here's the chamfer bit. Still looks clean. I ran it at 70% feed rate override, so that's 700 millimeters a minute, and I was in no rush. That way I get a pretty decent surface finish. Right there where you see that light on that line there, if you will remember from the video, that's where it did the lead in and the lead out. I forgot I should have done some overlap, and that would have helped eliminate that small little defect there. But hopefully nobody notices. So I just laid the plate on top, which I was tasked with replicating, and I wonder how I did. I mean, obviously these ain't no calipers, but as far as I can tell, everything seems to be well within spec. And honestly, I think my plate looks better. I mean, I gotta clean up the face finish, but the edges, although unfortunately the customer wants them sandblasted, so no more mirror finish. And this face finish here that I've done, I did manually at work on the Bridgeport mill with a pretty big fly cutter. Still didn't come out perfect because, man, this aluminum piece was warped, and as I was clamping and unclamping and moving it around, it was kind of moving up and down. But I'm going to give it a final sanding before the sandblasting. But man, I think this is a success. So I realized on that contour cutout I was doing, it was taking forever because I didn't check finish only at final depth. That's what I wanted. But so what I was doing the roughing pass, then it was doing the next pass, and then it was also doing the slow finish pass per every 1 millimeter depth. So, and my finish pass was at 700 millimeters a minute, 0.07. So no biggie, it still came out great looking, it just took much longer. But simple little things can make a big difference. So I used the blue painter's tape and CA glue method to glue this thing down. And it's on there very good. I kind of already tried to lightly pry it up with this flat blade screwdriver, but it wasn't budging, and I don't want to gouge the corner since it's a soft metal. So I'm going to heat it up with a heat gun first, soften up the glue, and hopefully it'll come right off. So I also additionally have to make these two pieces here. They're 20 millimeters wide and I forgot how long. And I want to get them machined out of this remaining piece of material left over from cutting the main plate out. But I couldn't fit them side by side. But I knew I could kind of pivot them and fit them. This one could be a little bit higher because of this notch. And I'm just confirming with these tool paths that they're far away enough to not cut into them. So, trying to maximize the use of the material. Hopefully it goes well. Alright, I've loaded the first code for the two additional little slider blocks. This is the first pocketing operation. It's gonna do 3 different pockets, 3 different steps. And then after this operation, I'm gonna actually drill and tap some holes into the waste board to hold them down before I do the contour cutout. That way when I do the cutout, they stay in place. But let's get the vacuum going, air assist running, spindle spinning, and we'll send it. Okay, another smooth operation. The face finish feels not too bad. I mean, a little rough, but I'm using a single flute cutter with no wiper flat on it, so it's to be expected. And my tramming might not be perfect neither. but I'm gonna sand it all afterwards anyway. So next thing I'm gonna do is I'm just gonna put 2 bolts in each of these, because then when I do the contour cutout, the remaining wall is gonna be very thin, and I'm afraid that super glue might not hold. So I'm gonna put a mechanical fastening or fixturing, that way just so we're on the safe side, and we'll see how that goes. Okay, so what I've done is I've drilled some 4.2 millimeter holes into the plywood and all the way through into the MDF where I could reach it, not these two. And then I started the threads with a tap just a little bit, and then I just used that to help start the bolts. And then the rest of the threads going down, I roll the threads instead of cutting the threads with the bolt. That way it's kind of like a compression fitting. So okay, we'll load the code and send it. Alright, that went pretty well. Miraculously, none of the little pieces came loose. I forgot I was gonna hot glue some of the other pieces surrounding it to make sure they didn't bust loose. But we got lucky. So let's vacuum up this mess and see what's underneath. My dust boot, definitely a little on the low side in terms of power suction, but the beautiful thing about the dust boot is that it does help deflect the chips downwards. Since I'm always running air assist, although it's not very strong, it blows the chips all around. But it helps keep it below the covers. I mean, some chips still fall through, but it's not too big of a problem quite yet. Here's what I mean when I say that we got lucky here, because these pieces get, pretty small. I mean, these are pretty big, but not these. This is the one I was worried about, and this one was already loose. When I was just vacuuming, it was wobbling around. So that could have busted loose and got caught up in my cutter. It might not have broken it. I've done some crazy stuff on here already, but why it's important to make sure everything's secured. I was gonna squirt some hot glue in there to support them, but I realized I would have messed up my contour, or my chamfer should I say, on here. So, slowly figuring this out. Hey, surprisingly, these feel pretty warm. This one feels almost hot. That's interesting. Thank God I do have them bolts. That would have softened up the glue really bad. But they came out good. There's still one more operation to run on these on the back side. So that's going to be fun and interesting. I'm going to have to re-indicate them and probably mount my vise onto the wasteboard here. But next I'm going to do the chamfers and put the holes in the correct spaces where they need to go. Alright, here is everything after the chamfering, and I like it a lot. This was the chamfer I was looking for, very subtle, very small. I didn't have much room for a chamfer with these holes here, but man, that came out height. Now, the only issue I have though is that the stock that I started with was not uniform in thickness. It was up to about 1/2 millimeter different. So back here the chamfer is actually deeper, so it does leave a bit of a knife edge. I'll just have to file that. Same thing back there. And then this one looks a little deep too, but this was the one I was going for. Very subtle, but I'm very happy how these pieces came out. Man, these are on there good. Maybe I can use my newly made tool. Nope. It's gonna take a little bit more effort. But man, that tape and glue probably didn't need those bolts. So here's something, man, I find hard to believe. So I'm measuring this distance that I've modeled just to make sure, and it's 80.6. And I'm measuring this distance, and it is just, I mean, it's exactly on there. That's impressive. And I did this diagonally. So I was a little concerned about how I was going to do the machining on the back side of these little slider pieces, but I realized I could just bolt them down through that slot like I did earlier. So again, I've got them spaced out from my reference edge so that I know this edge is parallel to the y-axis, and I'm going to probe it here to get my XY0, and then I'm going to run it. I'm just going to do each piece individually. There's just 2 of them, but I think that's on there pretty good. Okay, I've got the X and the Y zeroed out, and the Z. I got my code loaded, and we'll see how this goes. Looks like that came out great. We'll see how it fits. Hopefully it's good size. I want to show you all something real nifty. So these parts are designed to fit in these slots here, which can sometimes even be difficult just to insert. There's that one. And there's the other one. And to pull this off, man, was actually, well, not that it was difficult, but I think it was just very lucky. Maybe a little bit of skill. But this opening here is supposed to be about 81 millimeters. It's 80.8. And this one down here is about 80, 70.9. And now this is 70.6, and this is 80.6. No, 60, I'm sorry. So we're trying to be accurate to 1/100th of a millimeter here. So here we've got 80.61. And here, 80.64. There's still possibly some little burrs on some of these. Maybe that's where the lead and lead out was coming in. But that's really good. And not only are those widths pretty accurate, but so are these distances on the ends here, you know, relative to each other. And you know, I did the machining operations on the front side, and then I had to flip them and then locate it. And this feature, if it was offset by just a few tenths of a millimeter, then it would not fit in this slot. And it wouldn't fit, and it wouldn't slide so nicely. But both fit in both slots. And they fit both directions. And the reason that it's sometimes a little tricky putting these in is because you can't just put them in diagonally like that. They won't go in. You have to lift this side up to get the other side to go in. And look at how tightly those radiuses or radii come together. And look at it on the back side. There's almost no side to side wiggle. You can barely see it there. I mean, it just came out perfect. Last step I need to do is just to surface the back side of these. Because right now here they stick up a little bit above the surface. But they're supposed to be 1/2 millimeter below the surface. Which is why one of those pocketing operations I did was actually on the face surface. Well, let's zero this thing out with the depth gauge. 0.51. So man, I'm very impressed that just right off the bat everything came out, I think, pretty good. Here's the other plate. Just no complaints. Everything went smooth. Surfaces are phenomenal. Only thing I kind of wish I would have done, and I probably would have done if I didn't kind of run out of time, and well, after getting the confidence when I flipped these over and indicated them, after this came out so good, you know, I'm a lot more confident to flip the plate over and re-indicate it to do the backside chamfer. I guess I'm just gonna clean these back edges by hand, but it sure would have been nice to have both sides chamfered instead of leaving a sharp edge on one side and this beautiful chamfer on the other. But hey, we're just newbies here. Alright, I hope that video wasn't too long and boring. I try to make sure I demonstrated and showed how the machine works and how the surfaces look as they're being machined. Some places I try to show it real time, just the beginnings of the cuts, and then I speed it up just to get through it. The whole job took several hours, just kind of re-indicating, changing bits, loading code, making changes. And well, but it all came out pretty good. I'm very happy. I hope you guys enjoyed seeing the process unfold. If you want to get serious about it's like soft metal machining, man, this machine does it almost perfectly. Obviously you gotta definitely upgrade your spindle. The stock 400-watt spindle is just not the same thing. It is not at all, not even close. But I mean, this is just to get you started. You decide what spindle you want. There's a lot of people that go with the 65mm spindles, which go up to 1.5 kilowatt, but all those are limited to about ER11 or ER16. Mine's ER20. I went with that for multiple reasons, namely to be able to run some bigger tooling. My biggest single flute end mill, this thing is a beast. It's almost a fly cutter, 3/8 inch. But hopefully I'll be dishing out much more videos of what I'm making on here. And if you guys enjoyed it and you want to keep up to date, please subscribe and like this video if you can. Helps me out, and hopefully it'll help you out as well. If you guys have any comments or questions or things you'd like me to show, please leave your comments below. I would love to read them and obviously help influence my future video making. Thank you guys again so much, and take care.